Pluto made them come all close by. Pluto's circle crosses that of a couple of different planets. Pluto, the hard little planet, outwardly extends its close-by planetary association and is stirring up power on Earth. Progressing surveys recommend a conceivable issue with Neptune, raising issues among analysts and space devotees. Key figures like Neil deGrasse Tyson and Michio Kaku have sounded alerts about the implications of this limitless event. Anyway, how did Pluto come to be on a collision course with its contiguous planet, and what should this sublime clash propose for life on Earth? Be a piece of us as we unravel how something tremendous just banged into Neptune and how specialists have been left troubled by this gigantic inconsistency. Pluto, once hailed as a planet, went through an adjustment of its notoriety, being renamed as a dwarf planet because of its whimsical circle. Not enduring this minimization, Pluto earnestly enchants and seeks after the vast close-by locale. Later estimates from regarded scientists like Neil deGrasse Tyson and Michio Kaku have raised issues about Pluto's course and probable meeting with Neptune, demonstrating an approaching series of results between the two heavenly bodies that could have significant repercussions for Earth. Pluto's outing around the Sun stands apart because of its apex indent ascribes within our close-by nearby planet group. Its circle is essentially gigantic, crossing a wonderful measure of cosmic units. Taking into account its discovery in 1930, Pluto now can't seem to complete a full circle around the Sun. Adding to its personality is the significantly extended nature of its circle, a takeoff from the more traffic circle approaches followed by the giant planets. Moreover, Pluto's circle strays by 17 degrees from the ecliptic plane, giving its way a more extraordinary grade contrasted with that of the significant planets. The blend of Pluto's inclination and its bended circle gives layers of complexity to its direction. One noticeable perspective is its infrequent assembly with Neptune's circle. For around 20 years, throughout each circle, Pluto adventures closer to the Sun than Neptune, opposing suspicions based on their different situations within the close-by planetary framework. Digging further into Pluto's circle, it is enrapturing to notice that it's anything but a remarkable circle but rather a stretched one, suggestive of an oval shape. This prominent circle results in essential varieties in Pluto's separation from the Sun throughout its visit. At a nearest approach, Pluto goes within around 30 cosmic units of the Sun, while at its farthest point, it arrives at more than 49 times the distance of Neptune from the Sun. Furthermore, Pluto's circle is shifted at a point comparative with the circles of the significant planets in our close-by solar system. This tendency not only adds to the intricacy of its circle but also assumes an essential part in its interactions with specific heavenly bodies, particularly Neptune. When Pluto experiences Neptune, their gravitational impacts change their bearings over time. The versatile dance among Pluto and Neptune highlights the unique nature of our close-by planetary gathering. Even as Pluto was once viewed as a singular vagabond in the outer reaches, its close-by experiences with Neptune spotlight the interconnectedness of divine bodies, each using gravitational powers that shape the paths of others. In later years, progressions in observational innovation have helped cosmologists in tuning Pluto's activities with momentous exactness. This has prompted a more profound comprehension of its circle and its true capacity consequences for the stability of the outer nearby planet group. Even as the opportunity of an immediate effect among Pluto and Neptune remains low, the chance can't be totally limited, inciting kept following and testing by the galactic community. Notwithstanding its unassuming size and distance, Pluto continues to direct interest and curiosity among specialists and aficionados alike. The inquiry emerges: why hasn't there been an impact among Pluto and Neptune? The response exists in the gravitational influence from significant planets. Astronomers began centering on Pluto's way not long later. Finding it and its circle astonished them. Unlike most planets that stick near comparable planes as they circle the Sun, known as the ecliptic plane, Pluto stands out with its varied and oval-shaped circle. The secret grows while considering that Pluto's way crosses that of Neptune. In spite of these complexities, Pluto's circle remains stable, exhibiting the perplexing mechanics of space. Understanding how three heavenly bodies connect gravitationally, like Pluto, Neptune, and the Sun, is a huge challenge. It's much the same as anticipating where they will go based exclusively on where they start and how they impact each other. For Pluto, this adventure represents how its way, Neptune's way, and the Sun's impact cooperate in a mind-boggling reenactment of libration and the VSOP variations. These factors assist analysts with settling the huge question of Pluto's circle. A reenactment is significant for maintaining planets in their circles. While Pluto crosses Neptune's way, it is in any event 90 degrees away, forestalling a crash. Libration guarantees that even as Pluto approaches Neptune or other huge planets, it stays well clear of their way, reducing the gamble of a collision. The VSOP variations, named after scientists, explain why Pluto's circle appears unconventional yet remains stable over the long haul. In spite of the disorder in space, certain examples and rules keep things all together. These rules maintain Pluto's circle stable, forestalling crashes with Neptune or changes in its way. The chance of orbital chaos exhibits how a divine body's direction is exceptionally delicate to its initial position, as shown by Pluto. Even minor changes in its position or v-speed can radically change its circle over time. Scientists use PC reenactments to grasp how Pluto interacts with other divine objects like Neptune. By tweaking these reenactments, they can get a handle on how small alterations can affect Pluto's way in the long run. In the late part of the 1990s, these reenactments revealed fascinating aspects of Pluto's circle. Regardless of issues that could weaken it, Pluto's circle remains strikingly. He accepts it is essential to talk about how heavenly mechanics work. Tyson collaborates with different specialists to caution individuals about the potential dangers of Pluto's surprising circle. He centers around the chance of a future impact between Pluto and Neptune and how it could influence our whole planetary framework. A crash between Pluto and Neptune would be an extraordinary and critical occasion. It could discharge an enormous measure of energy and possibly break Pluto into pieces. Flotsam and jetsam from the impact could disperse through space, hitting different planets and moons. Neptune could likewise encounter the influence, changing its direction. Renowned hypothetical physicist Michio Kaku, known for his commitments to string hypothesis and innovation, has shared a charming viewpoint on space investigation. He trusts that understanding the fate of space travel and the connection between heavenly mechanics and hypothetical material science can be accomplished by. As Pluto navigates through the solar system, its unique orbital characteristics allow it to engage in a gravitational interplay with other celestial bodies, particularly the larger planets. This dynamic dance emphasizes the interconnectedness of the solar system, where even a small object like Pluto can exert and experience gravitational influences that shape its path over time. The inclination of Pluto's orbit not only contributes to its distinct trajectory but also affects how it interacts with Neptune and other nearby planets. This inclination means that Pluto's orbit crosses that of Neptune, allowing for periods when the two bodies can come relatively close to one another without the risk of a collision. This fascinating orbital relationship occurs every 248 years, creating a complex gravitational choreography between the two. During these encounters, the gravitational pull of Neptune can affect Pluto's speed and direction, resulting in a subtle but significant alteration of its path. This interaction showcases the delicate balance that exists within the solar system, where even minor gravitational influences can lead to substantial changes in an object's trajectory. Scientists closely monitor these interactions to enhance their understanding of orbital mechanics and the factors that govern the motion of celestial bodies. As our observational technology advances, astronomers have gained unprecedented insights into Pluto's orbit and its gravitational interactions. Sophisticated computer simulations allow scientists to model the complex dynamics of the solar system, providing valuable predictions about potential future encounters between Pluto and Neptune. These simulations reveal the intricate balance of forces at play and highlight the stability of Pluto's orbit despite its eccentricities. In addition to these gravitational interactions, scientists continue to explore the possibility of other influences affecting Pluto's trajectory. Factors such as the gravitational pull of distant celestial bodies, the influence of the Kuiper belt, and even the effects of the solar wind may contribute to the nuances of Pluto's orbit. Understanding these influences is crucial for deciphering the larger mechanisms at work within our solar system and beyond. Pluto's status as a dwarf planet has sparked significant interest in its composition and atmospheric conditions. Observations from missions like NASA's New Horizons have revealed a wealth of information about Pluto's surface and its atmospheric dynamics. As we learn more about Pluto, it becomes increasingly clear that this distant world is far more complex than previously understood. Its geological features, such as mountains made of ice and vast plains, challenge traditional notions of what constitutes a planet. In addition to its physical characteristics, the potential for interactions with other celestial bodies like Neptune raises intriguing questions about the future of Pluto. Although the likelihood of a direct collision remains low, the implications of such an event would be profound. A collision could lead to the fragmentation of Pluto, resulting in debris that could impact other bodies in the solar system and provide new insights into planetary formation and evolution. Prominent astrophysicists, including Neil deGrasse Tyson and Michio Kaku, emphasize the importance of studying these interactions to deepen our understanding of the cosmos. They argue that Pluto's unique orbit and potential encounters with Neptune serve as a microcosm of larger cosmic processes. By investigating these phenomena, scientists can gain valuable insights into the fundamental laws governing motion in the universe and how they apply to other planetary systems. As researchers continue to study Pluto's trajectory and its gravitational interactions, they remain vigilant for any changes that may arise in the future. The exploration of these celestial dynamics underscores the dynamic nature of the solar system and the ongoing quest to comprehend the complexities of the universe. Whether it be through the study of gravitational mechanics, observational astronomy, or advanced simulations, each discovery adds to our growing knowledge of the cosmos and our place within it. The dialogue surrounding Pluto's orbit highlights the broader significance of studying celestial bodies and their interactions. As we unravel the mysteries of our solar system, we are reminded of the interconnectedness of all things in the universe. Pluto, once relegated to the status of a mere dwarf planet, emerges as a critical player in the grand narrative of celestial mechanics. Through ongoing research and exploration, we continue to uncover the intricacies of Pluto's orbit, illuminating the remarkable forces that shape our understanding of the cosmos. In conclusion, Pluto's complex and eccentric orbit, coupled with its interactions with Neptune, represents a fascinating area of study within planetary science. As we continue to monitor and analyze these celestial dynamics, we expand our understanding of not only Pluto but also the broader mechanisms that govern the movement of objects in space. The ongoing exploration of our solar system promises to reveal even more about the delicate balance of forces at play, ultimately enhancing our comprehension of the universe and our place within it.